Good afternoon, viewers, and welcome to today's episode. Today, I'm going to talk technology and I'm going to introduce you to a branch, an emerging branch of artificial intelligence called Generational Adversarial Networks, GANs in short. And I'm going to give you an overview of how does the technology work, how is it applied, what are its use cases, how is it going to impact in the future, how does it differ from other deep learning technologies like convolutional neural network, recurrent neural networks, and so on and so forth. What are some of companies that are using it for what purposes, and what are its disadvantages? With that, let me kind of take you to the presentation on generational adversarial networks. An introduction. So there are about six distinct features of this presentation. We start with explaining what GANs are and how do they work, their impact on the future of business and on supply chains, how does it impact healthcare, manufacturing, content writing, some introduction to some companies using GANs, and a comparison between GANs and other neural networks and its limitations. With that, let's start with understanding what GANs are. Generational adversarial networks are a type of neural networks. And just to refresh your memory, a neural network is a processing system inspired by the structure of the human brain and consists of highly interconnected nodes, which are called neurons, that find patterns in data. And as a result of which, they solve what is called classical prediction and classification problems in data. Now, to give you an example of a prediction problem, it is to predict whether a particular customer is going to churn out of a life insurance product in, say, less than 3 years. And a classification problem is how does Google Mail kind of classify mails as spam mails, right? So GANs, however, is a part of a broader neural network which can generate high fidelity new data basis the data that on which it is trained for. Okay, so it creates artificial data mimicking the real world data. It could be text data, images, videos, and so on and so forth, which actually are resembling the original data, right? And the question is, how does this work? GANs is basically a combination of two neural networks pitted against each other in a game-like setup. There is a generator and a discriminator. Generator takes any input, either in the form of an image or a text, and generates data which is indistinguishable from the real data. So it creates high fidelity data over a period of time. Discriminator is the parallel neural network which is working in consonance and takes both real and data churned out by the generator, and it tries to distinguish between real and fake data. The goal of the discriminator is to correctly identify which data is real and which is fake. Now, these two networks get trained simultaneously on huge masses of data, where the generator is trying to fool the discriminator about a fake data versus a real data, and the discriminator is getting better to distinguish between what is fake and what is real. So over a period of time, this process continues, and the generator can create new data which closely resembles the data set on which it is fed, to the extent that it is indistinguishable, and the discriminator over a period of time cannot tell the difference between the real data and the generated data. For instance, this is real data, and I'm having a conversation with you and kind of loading it in the YouTube channel is a real data. Now, this is visual data, which a convolutional neural network can actually create an exact prototype of me, but talking in a different context, which will mimic me. Now, this is done by the generator. Initially, it will be a poor copy of it, but the discriminator will work on it to make sure that what you get as a final product is actually me, a prototype of me, which is not me, which is synthetic me or artificial me talking exactly like me. All right. Now, to understand, now, so this is quite surreal. You can actually have people, you can have politicians giving, you can actually create images of politicians giving fake speeches and so on and so forth. There are multiple applications. Now, to just to touch upon the technology behind it, uses deep learning algorithms, specifically convolutional neural networks or CNN, for image-based stuff or image-based scans, and regular neural networks, RNN, for text-based scans. For the uninitiated, the CNN is generally a neural network, which is in technical terms, it is called a fast forward back propagation neural network, which works on a particular forward sequence. There is an input layer in which data gets processed over hidden layers and an output is generated, but it is in one direction, typically used for kind of recording or identifying images and videos and so on and so forth. The recurrent neural network actually travels in both directions. While the CNN is one directional, recurrent neural network travels in both the directions and retains information, and it is used for predicting data. For instance, when you write in a Google Mail or you're typing something on an email, the Gmail actually predicts the next set of words that you're going to use. That is an example of a recurrent neural network. Another key technology that GANs use is a loss function, which actually measures the error between the generated data and the real data. The loss function is used to calculate the error and therefore to update weights of the neural networks. And as the loss function is minimized, the generated data looks exactly like the real data. Now, this might be a bit of a hyperbole and a bit confusing, and let me try and simplify it. In big ticket items, generative adversarial networks produce data of images or text which completely look like the original data set, and it has multiple applications across industries. Now, if you think about product and service innovation, GANs can be used to actually generate prototypes, products, or kind of real images of designs that are in vogue currently and enables product and service innovation. Similarly, marketing and branding, new visual content can be created, which is images or YouTube videos, without much effort, which creates engaging and personalized content, which helps you engage with your customer much better. The third important, probably the most important application of a GAN is to generate new data sets, which can augment machine learning models. And these new data sets can help making machine learning models or improve their performance and accuracy over a period of time, and which can be used for a variety of prediction and classification problem, either in supply chain, personalization, or what have you. The other important thing is personalization is a big digital trend. GANs actually enable hyper-personalization based on users' preferences and create content exactly what the user wants without much amount of customization for every individual unit. Similarly, consequently, if you were to extrapolate this understanding, the generative adversarial networks have a very, very big impact in demand model forecasting. Now, demand models are based on actual data, and you kind of extrapolate actual data to do demand forecasting. But with the data augmentation feature of a GAN, you actually use synthetic data to train the demand forecasting model with a much higher level of accuracy. Similarly, it has an implication of efficient logistics, which optimizes logistics and transportation routes. And we did talk about product and service innovation as a big impact area. Obviously, like furniture, apparel, consumer electronics, new and innovative products are based on user preferences. So these are the big themes on which the future of the businesses get impacted. With that, now let's look at some businesses and kind of some industries where GANs have a profound impact or a very early impact, which is evident. And I chose three. First, we're going to talk about healthcare. Healthcare, as we know, requires a lot of content to train doctors, paramedics on either administering a protocol or devising new protocols. Similarly, synthetic medical images of scans are used for training and research purposes, which helps the training process to become much more scalable and accurate. With that, medical diagnosis, improved diagnosis, MRI, CT scans, X-rays, the drug discovery cycle can be reduced by automating parts of the molecular design, and similarly, synthetic electronic health records can be scaled out to help doctors design new medical protocols. So that has a very significant impact on healthcare. In manufacturing, we did talk about supply chain a couple of minutes ago. It has an impact on product design, new prototypes, new product designs on certain industries can be created using GANs. Similarly, supply chain optimization, which is demand forecasting, bottleneck removal, predictive maintenance, where basically GANs are trying to identify patterns from machine sensor data that indicate which machine is likely going to fail, which enables you to take preventive maintenance. Now, these are industries that we know of. Creative writing and content writing is not an industry that is generally talked about, but GANs have a very profound impact on the content writing industry in terms of content generation. More importantly, from language translation, it improves the quality of translation by generating more accurate matches. Also, content optimization can optimize content for specific audiences by generating content that resonates with your interests and preferences. And similarly, creative writings, can create new scenarios, new scenes, and so on and so forth. But what I want to explain here in word of caution that Chat GPT is not a GAN. It's a different technology based on transistoring technology of labeling of data, which is probably a subject of another discussion. But as a word of caution, do not, by the way I am probably framing it, sounds like Chat GPTs, but this is a completely different technology. With that, moving on, these are some companies, big brand names that used GANs. However, talking about specifics, NVIDIA, which is the GPU manufacturer, world leading GPU processor manufacturer, has a product called Style Game, which is a GAN model, which creates very high quality human images with a higher degree of control over various applications and features, and is used for filming, gaming, or three-dimensional imaging, and so on and so forth, creating a new breakthrough and a completely new avenue of using high-fidelity data of images. Similarly, Amazon has invested in GANs through its Style Snap features, which allows customers to upload photos of clothing or any items to get recommendations for similar items from Amazon's inventory. So it does a perfect match based on the image that you upload. It kind of predicts what would suit well for me, taking personalization and the recommendation engine to a completely different league. While the classical personalization or the recommendation engine would work on, even the best ones would work on a combination of natural language processing on the kind of keywords that you search, or also convolutional neural networks on the visual images of something, the GANs go to the next step, which actually use feature extraction problems to kind of match to the nearest products, a completely a significant improvement on the current technology that we know of. With that, it would be very important for us to distinguish GANs from the other neural networks. And in this particular case, I'm going to talk about convolutional neural networks. So convolutional neural networks are used for classification tasks, which is recognizing objects in images. These are basically image classification tasks. It recognizes the image or identifies image or identify features in images, while generative adversarial networks actually create new data like from the training data. So these are both powerful technologies that work together or separately depending on specific goals and complement each other. So they are not competing technologies. With an example of the recommendation engine, right? You can use convolutional neural network with natural language processing to kind of curate recommendations or personalized recommendations for an e-commerce platform. The generative adversarial network uses a different technology to create high fidelity matches of the prototype that you are uploading, right? So it creates actually a new version of what is there with you to be able to make the match, while the convolutional neural network and an NLP combination would not create new data. It would actually classify existing data and still probably come to the same set of conclusions. The big picture here is, I mean, do not confuse one technology as competing to the others, but they are complementary. So in the entire family of neural networks, This is another powerful addition to the milieu of neural networks, if you may. Now, with that, I'm just going to spend a couple of minutes around explaining the limitations of GANs. Yeah, right. Obviously, the data bias, and we know this, and it is true for all artificial intelligence models. GANs can generate biased input if the input data is biased, right? Now, the other interesting thing, and probably the most important one, is the misuse. Yeah, it can be used for unethical purposes, creating fake images or videos, which has a very significant impact on the on the video on the news industry, where YouTube videos can be set up for malicious purposes. The technology is also resource intensive and lack interoperability, which is they are referred to as a kind of black boxes without knowing where it comes from. With that, I hope you had a good understanding of generative adversarial networks or GANs, and I'm going to kind of post some other videos on its use cases and probably chat GPT as we go on. Thank you very much for your time and happy viewing.